In the heart of Italy, the Bay of Naples is one of the country's most precious jewels. But the calmness of the sea is deceptive, as this is one of the most dangerous places on the planet. The volcanic activity is one of the highest in the world. The reason for this is the presence of volcanoes, such as Vesuvius, whose imperious cone looks down over the bay. Everyone here is aware of the cataclysmic eruption that killed thousands of people in the town of Pompeii. For the time being, the volcano seems to be quiet, and beneath it, 3 million inhabitants live a normal existence in a bustling 21st century metropolis amidst the grandeur of the city's ancient remains. Everyone knows that the monster could spit out its angry poison at any time.
We don't know when, nor with how much force, but we do know for certain that it will happen.
But the city is surrounded by another threat, which comes from a network of gigantic but almost invisible volcanoes, over which part of Naples lies. Any future eruption could destroy the region and half of Europe. And yet, for centuries, this mortal threat has not prevented humans from settling close to these giants, where some of the most fertile land is to be found. And these aren't the only dangers which weigh heavily on Naples. In Sicily, Mount Etna regularly spews out magma down its slopes, and it too could destroy the whole of the region. And not far away, Stromboli could at any moment trigger a tidal wave, swallowing up the city and its surroundings.
A wave would reach the port of Naples in around 20 minutes.
Scientists are in a race against the clock to bring the convulsions of these fiery monsters under control.
Etna is one of the volcanoes producing the world's largest amount of sulfur.
Both under the sea and on land, day and night, scientists analyze the slightest variations, which could be the signals of imminent eruption, using the most up-to-date technology. Will their tireless persistence enable them to foresee the volcanic rage? Millions of lives are depending on it. Vesuvius is the most famous volcano in history for the wrong reasons. Dating back to antiquity, its destructive flames engulfed the city of Pompeii and killed its inhabitants. Several eruptions since then have occurred in the region. But today, Vesuvius is not the most potent threat. On the other side of the Bay of Naples, a lesser-known fatal danger hangs over an area where 350,000 people reside. Beneath this enormous expanse of lowland lies a group of developing volcanoes, historically named the Phlegraean Fields, meaning the burning fields. This network of 72 volcanoes extends over a huge surface area of 100 square kilometers to the west of Naples, on land and under the sea. Compared to classic volcanoes with their recognizable cones, these ones are atypical and more or less invisible on the surface. They're classified as supervolcanoes, of which there are only 18 in the world. It's a most dangerous category because of the volume of eruptions that are produced. Today, this sprawling volcanic network is showing early warning signs of a massive eruption. Among the many craters in the Phlegraean Fields, it's a solfatara which is being the most closely examined by the world's volcanologists due to its intense activity. From this steamy, bubbling site, more than 2,500 tons of CO2 and sulfur are released from the depths of the Earth every day. Mauro De Vito is a volcanologist from the National Institute of Geophysics and Volcanology in Naples, the INGV. He is particularly concerned about this area. 4 years ago, a whole family died here in the middle of this crater when they were walking on its unstable surface.
If you walk on the crater floor, you can actually feel the chasms, because the molten rock is porous, and chasms are created underneath by the emission of gases. Under concentrated high pressure, the gases can erode the fine particles of the rock and create chasms below the crater level.
Nevertheless, despite this permanent danger, thousands of people live on the edge of the Solfatara. Just behind the Solfatara site, in the hollow of this cliff, another volcano is also bubbling away. This is Pisciarelli. 10 years ago, the owners of the tennis hotel nearby had to leave the premises.
Extremely hot and intense steam is being emitted. The temperature must be above 100 degrees. And these emissions are what's producing all this salt.
The walls and floors are being covered, like octopus tentacles, in a burning gas, which leaves a thick whitish coat and an acrid smell of sulfur in the air.
The smell is particularly strong here, a bit like rotten eggs, a smell which gets into the nose. We mustn't stay here long.
Pisciarelli was only a small hole a few years ago. Today, it's around 40 square meters and emits more than 600 tons of gas and steam every day, creating these striking fumaroles.
If, for example, there's an increase in one component compared to another, this could mean that magma is moving towards the surface. So any variations will give us an indication about how the system is evolving and whether an eruption is imminent.
After detailed analysis, the scientists come to a cast iron conclusion. The Phlegraean fields will very soon erupt. This will be catastrophic for the inhabitants. The Campanian ignimbrite eruption was the most spectacular eruption in the history of the Phlegraean fields. It spewed out more than 300 cubic kilometers of magma, a formidable amount never equaled in the region, and ejected millions of tons of porous volcanic rock called pumice stone. Scientists also discovered that 15,000 years ago, this monster produced a second major eruption, this time ejecting a volcanic rock called the Neapolitan yellow tuff. These destructive byproducts were nevertheless used by the Greeks and Romans to build their cities. The whole of the city of Naples was constructed with this material, which is what gives it such a unique character. Claudio Scarpati is a professor of geochemistry and volcanology.
Here we have some splendid examples. The Gesù Nuovo church is composed of fragments, blocks of stone extracted from the Campanian ignimbrite, whereas behind me is the Santa Chiara church, which you can see is entirely built from blocks of Neapolitan yellow tuff. To some extent, you could say that, thanks to the extraction of this material from beneath the city, the outline of Naples is the positive image of a negative.
For Claudio Scarpati, there's another spot which highlights Roman ingenuity. Situated on the other side of the city, it's a masterpiece, also built from volcanic rock.
We're in a huge freshwater reservoir. It's an impressive technological feat. The pillars are 15 meters tall. The reservoir contained 12 million liters of water, which helped to keep afloat the Roman fleet based nearby at Capomiseno.
This was the only reservoir of this size built entirely into the rock in the whole of the Roman Empire. But the Neapolitan yellow tuff does have one major drawback: it's porous.
In order to waterproof the walls, They had a clever idea. They made a special kind of mortar. It's a cement-based mortar called cociopesto. It's basically made of three elements: brick fragments, limestone, and the most important element, puzzolana, volcanic ash, of which there is an abundance in this area. They mixed these three things together, and once set, it made the walls totally waterproof. This then enabled the reservoir to contain such huge quantities of water.
Today, the imminent eruption of the Phlegraean fields threatens to destroy what the Neapolitans spent centuries constructing. And in this zone of ever-present danger, there's another enemy, both more visible and more familiar, which continues to worry the inhabitants. Vesuvius has been a brooding presence for centuries, reminding Neapolitans that its strength is intact and its anger can still rain down on the city. Its last eruption in 1944 has stayed fresh in people's memories. Its flames destroyed whole villages over a period of 11 days, with a death toll of 26. Vesuvius has been dormant since then. But this deafening silence is a source of worry for many scientists who have been examining the volcano in detail since the middle of the 19th century. Modern volcanology was born on the flanks of Vesuvius. Mauro De Fido comes from a long line of illustrious predecessors and continues to watch the potentially explosive volcano, which is capable of ejecting tons of ashes in a matter of moments.
For us Neapolitans, Vesuvius is the ultimate volcano. It has dominated our culture, and I've always been strongly attracted to it. And for those of us who work a lot in this domain, it's important to point out that we find something new about it every day.
Mauro De Vito studies the stratigraphy, the geological layers of the volcano, nicknamed the exterminator.
When volcanologists study stratigraphy, it's as if we're reading a written account, turning page after page of the history of the volcano's eruptions.
The accumulation of the different layers enables the volcanic activity to be retraced a long way back. The oldest eruption dates back 400,000 years, and the most recent was the one in 1944.
The reddish-grey layers correspond to an eruption plume, which rose 6.7 kilometers into the sky and deposited ash over a huge area as far away as Calabria. The final phase is shown by this light grey layer, which is where the magma chamber was virtually emptied, followed by water that entered the system, entailing other extremely strong explosions.
Today, the seemingly calm Vesuvius does not fool the scientists. They know that it remains dangerous and very much alive, registering over 700 seismic tremors every year. 600,000 people live in close proximity to the volcano, so it must be watched 24 hours a day.
This instrument measures the flow of CO2 and the temperature of the gas emissions. It also enables us to have a more general idea about the evolution of the volcano. It's very important to understand the system because it can give us an indication about the possible movements of magmatic currents. This is one instrument, among many others, which enables us to listen to the volcano's breathing.
The volcano's breath are the gases dissolved in the magma. When they rise to the surface of the crater, the pressure drops and the gases expand. They form bubbles which spread over the surface.
It's a bit like what happens in this bottle, which contains a gas-rich liquid. As soon as you alter the pressure by removing the cap, you can see the gas separating from the liquid and rising to the surface.
In order to understand the origin of volcanoes and magma, we have to go back to the beginning of the Earth's history. 250 million years ago, the continents that we know today were all one, the Pangaea. But as a consequence of geological activity, this supercontinent broke into a dozen tectonic plates, which separated and drifted apart to form the continents of today. The geological cause of these movements can be found beneath the Earth's crust. This layer is 30 kilometers thick, which is nothing compared to the 6,000-kilometer radius of the planet. Between this crust and the Earth's core, whose temperature is a furnace-like 5,000 degrees Celsius, there is an upper mantle 650 kilometers deep. This mantle consists of molten rocks whose currents circulate around each other. They act like moving walkways and displace the plates of the Earth's crust. This is called convective movement. Over millions of years, these plates drift apart by several centimeters per year. They slide, separate, and collide. In Italy, the African plate slides under the Eurasian plate. In the geological wars of the Titans, the contact points can reach such high temperatures that part of the mantle's rock fuses. This then brings about subduction. The molten rock, magma, builds up in the crevices of the Earth's crust and forms magma chambers. Eventually, magma combined with gas will rise to the surface and form a volcano. When an eruption occurs, the magma discharges accumulated heat and energy, thus helping to balance the structure of the Earth's crust. But the release can also cause the destruction of life on the Earth's surface. Vesuvius and the Phlegraean fields are the two most potent threats which inhabitants of the Bay of Naples have to live with. But they're not the only dangers, as other volcanoes cast their shadows on the region. Only 500 kilometers south of Naples, in Sicily, is Mount Etna, one of the most active volcanoes in the world. With over 80 eruptions in the last century alone, this 3,340-meter-high monster, nicknamed the Mongibello, the Mountain of Mountains, is a volcano which erupts more or less all the time, in contrast to its Neapolitan cousins. Eugenio Privatera has been visiting the site to examine and analyze the volcano's output for 37 years.
We can find all these lapilli, which are debris from explosions. They're small and very light. This is because they're full of air bubbles, or originally gas. We can also find volcanic ash, and as you can see, it's like very fine black sand. And here is a lovely volcanic bomb. It's quite big, but not as big as some produced by Etna. Some bombs can be the size of small cars. This rock was produced from within a magma column. And when the gas bubbles reach the surface and expand, they project into the air the part of the magma situated above the gas bubble.
The phenomenally strong giant volcano is constantly creating new craters. Bocca Nuova is the most recent of them. It was spewed from the bowels of Etna in 1968 and is one of 4 craters on the summit, which permanently emits burning vapor from the depths.
As you can see here, the activities of the fumaroles are very visible. The yellow of the sulfur, too. Etna is the largest producer of sulfur of the world's volcanoes. It produces on average around 4,000 tons of SO2 per day, which is around 10 times more than any other volcano.
But why is Etna a volcano in permanent eruption in contrast to its Neapolitan cousins nearby? What geological properties make it so dangerous? Unlike the volcanoes of the Bay of Naples, Etna is situated on the crossroads of several tectonic plates. It's in contact not only with the Eurasian and African plates, as in Naples, but also with the microplates of the Turanian and Ionian seas. These geological confrontations produce huge quantities of magma, which in turn generate this intense activity. The magma is relatively fluid, and the gas bubbles move freely. They therefore rise to the surface quicker than the magmatic liquid. This is a major difference with Vesuvius and the Phlegraean fields. For the latter, the magma is much more viscous and sticky. It's harder for the bubbles to move as freely, and they rise at the same speed as the magma. Once at the surface, there are so many of them that they form a foam which is unstable and breaks up, generating explosive eruptions. Whereas with Etna, the small gas bubbles join together to make larger ones, which rise in the vents quicker than the magmatic liquid. When they reach the surface, they burst, creating mini explosions which project the magma into the air. Once separated from the gas, the magma spreads and forms lava flows, which we call effusive eruptions. But today, the volcanologists are very concerned because Etna is showing symptoms of a fever that is hitherto unknown.
One of the most recent discoveries we made about Etna is that the chemical composition of the magma has been changing over the last few decades. There's now an increase in potassium, compared to before when there was more sodium. This chemical variation could explain the rise in explosive activity that we've noticed over the last few years, and the fall in effusive activity.
This change in behavior, which has worried scientists, has led them to perfect a new technological tool adapted to Mount Etna.
So, how is it today?
Hi, Eugenio. I'm in the middle of checking the signals, but for the moment I can't see any important variations. The variations in the Earth's gravitational fields are one of the parameters which help us to examine and study the activity of the volcano. This is a gravimetric station, and this is a gravimeter. What we are measuring are the variations due to the distribution of the magmatic mass beneath the crust. We're able to see and localize the position and depth of the source, and also to define the mass at stake, and work out how much magma is on the verge of erupting, for example.
Despite the huge 1,200 square kilometer surface area, Etna is the most monitored volcano in the world, and the volcanologists are constantly on the lookout. They're divided into a whole series of laboratories situated all over the mountain, so that no activity goes unaccounted for. But these measuring instruments are not enough to understand the behavior of this imperious dragon, which is over 1.5 million years old. Scientific study is never-ending, and Eugenio's investigations take him to the other side, which bears the scars of the ancient history of Etna, the Bove Valley. On a scientific level, it's like an open-air museum. On the geological level, it's a huge depression, 5 kilometers wide and 10 kilometers long.
The formation of the Bove Valley has enabled us to understand the inside of volcanoes that were active between 160,000 and 100,000 years ago.
Before being transformed into this huge depression, the Bove Valley was an enormous volcano. When the volcano collapsed into itself, magma deposits were produced in the shape of huge blades sticking up from the rocks, called dikes.
Imagine that we're inside a volcano. Around us, there is only volcanic rock. And at some point, the pressure of the magma inside increases. It starts to break up the rock, making the split wider and even filling in the split. So the magma rises up and causes an eruption on the surface. That's the origin of this magma, which now looks like it's been frozen.
The dikes are just extra clues which help to reconstruct the internal behavior of the volcano during its eruption. Thanks to the constant activity of Etna, the volcanologists can follow how the volcano works day by day and spot even the tiniest variations which could be precursors of an imminent eruption. Alerts are frequent in this zone, so close to Naples. Several kilometers north of the Sicilian giant can be found underwater monsters, such as Marsili, the largest European volcanic area, situated at a depth of 3,500 meters. Nearby, in the Aeolian Island chain, off the island of Panarea, another colossus is reawakening. It's a new worry for scientists who are tracking this submerged volcano closely. The first indications of this underwater activity were observed by chance in 2002 by the volcanologist Francesco Italiano and the National Institute for Environmental Protection and Research.
Arnaldo, can you see? Look, you can really see the bubbles that are rising to the surface. These are the most intense hydrothermal emissions that we've seen here in Panarea. It's all carbon dioxide and a lot of hydrogen sulfide. You can smell the sulfur in the air. That's the first thing we noticed when we came to study Panarea. What we didn't expect at the time was that under the sea there was a whole world we couldn't see from above.
This activity is not good news for the researchers, because they thought this undersea volcano had been extinct for more than 600,000 years, an absolute eternity.
It was a huge surprise to discover that the fluids were rising to the surface in chimneys, 3 to 4 meters high. It was such a surprise because it meant that the fluids were finding their way upwards through these ancient structures, all fed by a volcano. So we deduced that there was a major hydrothermal system that we needed to look closer at.
Over the centuries, these hydrothermal fluids have painstakingly forged more than 200 chimneys, chiefly out of iron oxide, which is what gives them this red-orange color. This mineral forest is only 70 meters below the surface, which makes it an exceptional observation site for scientists. Elsewhere in the world, this type of geological formation is only found in the deepest of chasms. This extremely handy spot enabled Francesco Italiano to make a most extraordinary discovery.
These are grains from iron oxide shells, which form around each other, creating what we call ooids. It's the same type of deposit that has been photographed on Mars. We know that, on Earth, the origin of life is linked to hydrothermic systems in which life forms use chemical elements to survive. Seeing that we have the same underwater hydrothermic system on Mars could mean that there are forms of life on the red planet, too.
The undersea volcano of Panarea has today become a giant laboratory, and the scientists are only just beginning their investigations. All over this section of the Tyrrhenian Sea, volcanic activity bubbles away constantly. Just opposite the Isle of Panarea, another volcano, feared by humans for centuries, rises out of the sea, Stromboli. It's one of the most active volcanoes on the planet. It spews out its incandescent lava day and night, earning it the nickname, the Lighthouse of the Mediterranean. 926 meters high, it belongs to the category of stratovolcanoes. It was built up by many layers of hardened lava. But recently, volcanologists have been, above all, preoccupied with the north flank of the island, the Sciara del Fuoco, the Stream of Fire. It's a depression 1 kilometer wide and 1 kilometer long, with a very unstable 45-degree slope. In December 2002, what scientists feared would happen took place. The Stream of Fire was the scene of a spectacular event. On that particular day, 20 million cubic meters collapsed in one go and slid down into the sea, generating a 6-meter-high wave over more than 40 kilometers around the island and setting off a tsunami. Scientists now know what caused this geological catastrophe. When the magma reached the surface, it caused this part of the volcano to be deformed and to start swelling. When the elasticity of the rock reached its breaking point, it started to crack in numerous places, causing landslides, which, when reaching the sea, brought on a tidal wave. Mauro Rossi is a volcanologist. He has developed with his team new technology enabling this extremely unstable flank to be monitored.
What's the radar reading?
All stable on the Sciara.
Thanks to this high-resolution radar, the scientists can now track, image by image, the slightest movements of the terrain 24 hours a day.
To produce images of the movements of the Sciara del Fuoco, the machine works like a photocopier. If there have been any shifts of land, these will be picked up by comparing two images, and it could mean that there's a risk of the Sciara del Fuoco collapsing.
Mauro Rossi is still haunted by the memory of the 2002 tsunami. When he was carrying out research on Edu, the other name for Stromboli, he was reminded about the terrible events that occurred in Naples in the 14th century, as described by the Florentine author Petrarch.
There was a huge tremor in Naples, a loud noise during the night which woke everyone up. In the morning, down at the port, corpses and wounded people were scattered in the water. He wrote, broken like soft eggs, floating on the water. When the theory was put forward that Edu could have been the cause of this deadly tsunami, that's when I decided to come to Stromboli, to look for evidence that a tidal wave had indeed taken place at that precise time.
It was in the village of Stromboli, 4 meters buried under the ground, that he found the tangible traces of this disaster that was written about nearly 700 years ago. What we found was this brown-colored substance, which is of volcanic origin. The most interesting part was this layer, which also contains these big round pebbles. Discovering this stratum is irrefutable proof that the origin of the disaster was indeed a tsunami. Carbon-14 dating enabled us to date the layer just underneath to the middle of the 14th century. This would make it totally compatible with the tsunami that Petrarch observed in Naples. By measuring the thickness of this layer and its distribution across the island, Mauro Rossi was able to prove that the tidal wave reached a height of over 20 meters. In 2019, some holidaymakers were nearly drowned by a similar wave. Since then, the whole island has been under a permanent tsunami alert. After years of investigations, Mauro is now convinced that the deadly tidal wave which hit Naples in the 14th century could easily happen again.
If another tsunami was to be formed, because of a landslide on the Sciara del Fuoco, the wave that would be created would travel northwards and reach the port of Naples in about 20 minutes.
In only 20 minutes, the port of Naples and surrounding areas would be completely destroyed by a giant wave triggered by an eruption on Stromboli. This would be one more potential catastrophe for a region already living on borrowed time. Between the Phlegraean fields, Vesuvius, Etna, the undersea volcano of Panarea, and Stromboli, the 3 million inhabitants of the Bay of Naples have had to learn to live with this permanent threat. They're perfectly well aware of it, especially as they all know about the cataclysmic eruption that destroyed the city of Pompeii 2,000 years ago. In the year 79 CE, during the night of October 24th and 25th, Pompeii, a city 30 kilometers south of Naples, was consumed by the fires of hell. At the time, Vesuvius was thought to have been extinct for 800 years. But that night, the volcano woke up. Today, after many centuries of excavation, the remains of Pompeii are a unique treasure trove for scientists. This exceptional archaeological site has enabled Claudio Scarpati to decipher on the spot the evolution of the eruption and its destructive impact on the human population. The geological clues found at the end of this Roman road have helped Claudio Scarpati to make a detailed analysis of how the catastrophe played out.
What we can see here is the whole sequence of events that occurred in 79 CE. There are two main layers. A lower layer, which is made up of pumice, with stones of different sizes. Then there's a clear separation, and the upper stratum is composed of layers of ash. These are the two main phases of the eruption.
These observations have enabled scientists to partially reconstruct the first phase of the eruption. A massive column from deep inside the volcano rose at an average speed of 400 meters per second. It contained thousands of tons of ash and pumice. The magnitude of this rapid eruption was 50,000 times more powerful than the bomb dropped on Hiroshima. According to the scientists' calculations, 10 billion cubic meters of pumice and gases were ejected by the eruption. The plume of smoke reached 32 kilometers into the sky, which is more than 30 times higher than Vesuvius. The eruptive column in high altitude took the shape of a pine tree, as witnessed by the writer Pliny. These types of eruption now carry his name, Plinian eruption. During the first phase, pumice stones rained down on the inhabitants of Pompeii, who had no time to flee. Instantly frozen in time, these corpses bear witness today of their moving and desperate attempts to escape the deadly breath of the monster. In the 19th century, during archaeological excavations, the scientist Giuseppe Fiorelli perfected a brand new technique which enabled petrified bodies to be kept intact. When digging down into the 5 meters of ashes which had covered Pompeii, Fiorelli came across strange-looking cavities. By examining them closely, he realized that he'd come across the remains of a victim's body. In actual fact, over the centuries, the body had decomposed, leaving its negative imprint in the ashes, which had compacted around it. Fiorelli's idea was to inject plaster into these empty spaces. Once the plaster had hardened, the surrounding ashes were removed, and the body could be seen in its exact position at the time of death.
You can see the expression on the face and the position of the body. This is vitally important because it allows us to fix the person's last moments and to understand what actually caused their death.
After 19 hours of this devastating ash rain, the nature of the eruption changed and entered into its second phase, which was even more deadly. The pressure of the gas dropped and could no longer maintain the plume of smoke 32 kilometers in the air. The gigantic mass collapsed into itself, and an avalanche of fire, called pyroclastic flows, spread out of the volcano. The speed of this deluge of ash clouds is estimated at 240 kilometers per hour. In the ruins of this Roman villa, the archaeologists discovered victims from the second phase of the eruption. This couple remained united to the end. One of them seems to be desperately protecting the other, as if their arms could act as a rampart against the volcanic flames.
These victims found themselves inside a cloud, which was probably dozens, if not hundreds of meters thick. A cloud of ash, pumice, and volcanic gases, probably reaching temperatures of 100 degrees. They were undoubtedly suffocated by the density of the ash, which was found in the pyroclastic flows, and they would have died within minutes.
Claudio Scarpati's scientific approach is to examine the remains of the past in order to anticipate the future. And he's not the only scientist to ask the worrying question, will Naples become a second Pompeii?
What's interesting is that generations born after the last eruption in 1944 have never seen the volcano erupt, have never seen the famous plume of smoke above Vesuvius. And so they see a volcano which is calm, dormant, and which need not be feared. But on the contrary, it's a very active volcano, which could erupt intensely at any time. We don't know when, nor with how much force, but we know for certain that it will happen.
In the Bay of Naples, the highest priority remains the surveillance of the Phlegraean fields. Scientists often wait for sunset to begin their task of tracking the slightest tremor from the monster, which could alter the fate of millions of people. Tonight, armed with their thermic camera, Enrica Marotta and her assistant have come to observe the seething volcano of Pisciarelli.
It's vital that the sun's rays don't influence the temperature of the magmatic chamber. So that's why we work at night. At the moment, we can see the maximum temperature is 85 degrees. If we move the camera and focus on the fumarole zone, we can see that there is a huge amount of energy and considerable gas emissions, something which wasn't happening 10 years ago. It's impossible to go there now, so that's why we use drones.
This drone can fly up to an altitude of 100 meters and cover the whole Pisciarelli area. It's a fully expanding zone which is gaining ground on the city.
Here, for example, we have a surface area of around 1 kilometre. We can see straight away which are the zones with the greatest thermic anomalies. Over time, we can work out if these abnormal zones are rising or falling in temperature. This then gives us an idea on the situation of the magmatic system.
Enrica carries out these monitoring procedures every month, since the signs of volcanic activity are more and more concerning. The proximity to inhabited zones could lead to disaster. And as if the threat of eruption is not enough, there are other dangers linked to volcanoes. The town of Pozzuoli is right next to the Pisciarelli volcano. In the 1980s, a movement of panic overcame the inhabitants due to a very rare geological occurrence, Bradysism. Bradysism is a phenomenon linked to the change in the volume of gas in the magma chamber. When the chamber is saturated, the mix causes a gradual uplift of the chamber, deforming the rock. This deformation creates cracks which can reach the surface and bring about small earth tremors. The hot magma can then escape from the fumaroles. Inversely, when the chamber is emptied of gas, the pressure drops. This then causes the rock to be deformed in the other direction and the ground collapses. It's a bit like the breathing in and out of the volcano. For Mauro De Vito, the Bradysism is not something new to Pozzuoli. By observing the ruins of an old Roman market near the port, he discovered in the Temple of Serapis proof of this uplifting. He was particularly intrigued by the presence of small holes 6 meters high up on the columns.
What does this column tell us? That certain organisms, in this case bivalves, who live in the sea, made holes in the columns. This means that the sea was once at this level. And putting a date to these mollusks, thanks to archaeological dating, we realized that the temple was submerged for a long time. It started in the Roman era and carried on up until the 12th or 13th century.
Of course, when the temple was built, it was on dry land. But because of the fluctuating activity of the volcano, the land sank and the sea flooded the area. Centuries later, gases slowly accumulated again and lifted the crust back to its original level. In the Phlegraean fields, it's not the sea level which changes, but the ground level. For Mauro, one thing is sure, and that is, since a major Bradysism crisis of the 1980s, things are evolving in a dangerous fashion in the Pozzuoli region.
A very slow uplift began in 2006, stage by stage, accompanied by seismic activity. And then from 2018, the rhythm has been more or less constant, with an important increase which is still going on today. The total deformation from 2006 to the present day is around 70 centimeters in the central zone of Pozzuoli. This is certainly one of the reasons that I'm worried, but I can't give it a time scale. We cannot know or say if the next eruption will take place tomorrow, in 6 months, or in 20 years.
If an eruption did take place, it could look like this, according to the scientists. An eruptive column of around 15 to 20 kilometers high would be created, ejecting huge blocks of magma and tons of ashes, which the wind would carry to Naples and beyond. "30 minutes to evacuate the region. That's how long the volcano would allow the 3 million inhabitants. A ridiculously short amount of time." At the Pozzuoli Civil Protection Center, security teams are on maximum alert. In the event of an eruption of the Phlegraean fields, this zone is the most under threat in the region.
Thank you, everyone, for your assessment of the situation.
Mauro Rossi, the Stromboli volcanologist, is also responsible for the monitoring operations in the region. Every 2 months, he comes together with experts in civil protection and volunteers to organize evacuations in a zone of 120,000 inhabitants.
Obviously, if the conditions were such that we had to pass to a level orange alert, the evacuation plan for the whole of the Phlegraean zone could happen in 2 ways. Either autonomously, using their own vehicles, or by assisted evacuation for those physically incapable of leaving by themselves.
Everything is ready on paper, but for the moment, nothing has been tested on the ground in towns of often jumbled, cluttered streets. The problems here are not just logistical, but also sentimental. These inhabitants are extremely attached to their land, even if it represents a danger to their existence.
I'd prefer to die here, where I was born, and where all my ancestors were born, because I'm an old Putialano. It's in my blood. It's not something you can explain. You're born, you live, and you die here. What the scientists say is both true and worrying, but we're staying here, and what will be, will be.
Humans have lived here forever, alongside the volcanoes, which are an integral part of their culture. People know that the wrath of the volcanoes could bring about their destruction, but they don't let this stop them from living their lives. Neapolitan culture is based on this ambivalence, which is rooted in tradition and in religion. The people are at one with this land, which is blessed by the gods, and nothing or no one will ever separate them. Today, scientists know that the countdown has begun, and they're doing everything they can to avoid a human disaster. The battle is being waged on several fronts, and it's enabled them to make an unexpected discovery concerning the activity of its undersea volcano in the worrying Panarea zone.
We're on the fault line.
This time, the volcanologists have given way to the biologists.
Simon, can you see where we are? We should be there, shouldn't we?
Yes, this is the zone of the chimneys that we saw in 2015.
To better understand this zone with 200 chimneys, scientists are using a rove with its high-definition camera and articulated arms. A robot just like those sent to explore planet Mars. Remotely controlled from the surface, it can get right up close to the hydrothermal chimneys, which have never been much explored.
These are the chimneys that we discovered 5 years ago. What is striking is all the living creatures surrounding them. Because around the chimneys, there are fairly extreme conditions. For example, a very acidic pH level and CO2 emissions, which are higher than in other zones. But the whole of the zone is full of life, and so it seems the organisms have adapted to their environment.
It's an astonishing ecosystem, because in such extreme conditions, with very high levels of gas, life ought not to be viable. The biologists explain this by the presence of bacteria which feed on the minerals produced by the gas. And by transforming them into energy, the bacteria sustain the whole area. This is a clear sign that life can exist in a volcanic environment where an explosion can bring destruction, but also create life. The progress of science is vital to enable researchers to pierce the mysteries of one of nature's paradoxes. For millions of years in the region of the Bay of Naples, living in the shadow of volcanoes means living in one of the Earth's actively turbulent zones, where the end of one world could bring about the beginning of a new one.